Dr. Sara Appleton-Knapp is an associate professor of psychological sciences, and she teaches courses in cognitive psychology, learning and memory, and the psychology of advertising. Her research centers on how memory works, particularly the automatic processes that enhance memory, and how these processes interact with areas like diet, obesity, and advertising. As a member of the renowned Bjork Learning and Forgetting Lab at UCLA, Dr. Appleton-Knapp completed her master's and PhD in cognitive psychology, following earlier degrees in marketing and psychology from UCLA and UC Irvine, respectively. She's received funding from the National Institute of Health to explore the relationship between memory and obesity, and to develop strategies for improving memory through dietary interventions. Her work bridges multiple disciplines and reflects a broader interest in the practical applications of cognitive science in everyday life, from eating habits to consumer decision-making. In addition to her research and teaching, Dr. Sara Appleton-Knapp has served in academic roles at both San Diego State University and UC San Diego, contributing to high-level research projects and student mentorship. Her interdisciplinary background in psychology and marketing has given her a distinctive perspective for examining the cognitive mechanisms behind product memory and advertising effectiveness. Please join me in giving a warm welcome to Dr. Sara Appleton-Knapp.
Well, I want to thank Mortar Board for inviting me. When I get out of bed in the morning, what motivates me is to come and be here with you guys. I see a lot of my students here, and I love learning from you and being able to share the things that excite me. So tonight, I have a few things that I want to share with you that I find really interesting, and I hope you will find useful. So first of all, I want to talk about memory because that's what I study, right? And I want to talk about how memory can help you learn better, right? So this is useful for those of you who are still coming back here next year. It's useful for those of you who are going off to do something else, whether it's a job or grad school, right? It's always good to be able to learn more efficiently, right? And I also want to talk about how we have different neural architecture, right? So each of us has slightly different way that our brains work, and that sort of challenges the idea that there's one way to experience the world, right? And so I want to talk about some of the different cognitive traits that make us unique. And I also want to talk about artificial intelligence because this is something that I hear from my kids. It's something I hear from my students. AI is going to take my job. What do I do, right? And there are a lot of differences between AI and how humans work and how humans think and create. And so I want to go through some of those to sort of hopefully reassure you. So let's start with memory. When people learn that I study memory, the first question is, how do I improve my memory, right? And I always start by giving the example of learning names, right? So you go to a party, you meet somebody, you learn their name, and you think, oh, I need to remember this person's name. So what do? You say, okay, I meet Haley, right? Okay, so Haley, in your head, you repeat it, right? But the problem is that doesn't do anything, right? It doesn't actually help you remember. It helps you remember for that moment, but 10 minutes later, your friend comes in and is like, oh, who is that? And you're like, I don't know, right? And so what actually you need to do is you need to do retrieval. And so when you retrieve something from memory, you all have this, you're on a test, you see, you see a test question, you're having to think of what you've read in the textbook or heard in lecture, that's retrieval from memory, right? But what's interesting is that retrieval actually is a learning event. That retrieval causes you to remember whatever you're retrieving better, right? And so if you are retrieving the name, you want to make sure that there's some space between when you learn the name and when you retrieve the name so that retrieval is effective, right? So it's kind of like if any of you lift weights, if you lift a heavier weight, it's going to have a bigger impact on your muscle, right? Retrieval works the same way, that if the retrieval is harder, then that retrieval is going to be a more potent learning event, right? So ideally, you want to retrieve the name right before you would forget it, right? And so you can't exactly judge right before you would forget it. And so instead, what you should do, if you're at a party, you meet someone, you say their name, you look at them, you look at cues, what they're wearing, what their hair looks like, right? Okay, so you have the person in your head, And then a couple minutes later, you look across the room and you remind yourself, oh, yeah, that's Haley. Okay. And then maybe 5 minutes after that, you look across the room and you remind yourself, oh, yeah, okay, that's Haley. I know that, right? So then a half hour later, when your friend comes in, it's like, oh, hey, I'd like to introduce you to this person that I met, Haley, right? Because because you've had this retrieval practice, right? Okay. So this is partly due to the spacing effect, that when we see information, we encounter information, if there's space between it, we'll retrieve having seen that or heard that information before, right? And that causes us to learn this information better. So when your professors tell you not to cram, this is part of the reason why. So relearning, when you are studying for an exam, right, you review the material and you feel like you have a really good grasp on it. Now, unfortunately, if you do this the night before, then that's it. That's your learning, right? But to really learn something and to have it be available long term, what you want to do is you want to refresh your memory, right? So this is a forgetting curve. You learn something, and you over time you forget. So a couple days later, after you learn something, you're only going to remember maybe 10% of what you've learned, right? But if you review, so maybe a day later you review, that resets this learning curve or this forgetting curve. And not only does it reset it, but you can see it becomes less steep, right? So here, a couple days later, instead of only remembering 10%, now you're remembering 30%, right? You review it again, this becomes less steep. So here, now you're remembering 70%, right? And so this idea of refreshing your memory, it resets that forgetting curve, right? And so you can do that refreshing of your memory by reviewing, but you could do it by retrieval, and that would even make it more potent. So, using flashcards, for example, or testing yourself. Those are all methods that you can retrieve. Another one is visual imagery. So this is something where, you think about, you can see, some people are visual people. We'll talk about that in a little bit. Some people really resonate with things when they're visual rather than just words. And visual imagery is super important. So if you've ever been to a wedding, right? I don't know if you're probably not old enough yet, but if you've been to a family member's wedding, they have these tables for like 8 people, and they put 10 people because they want to not have as many tables. And so you're faced with all these drinks and bread plates, and what do I do? And I don't want to take the person's drink, and so this is a visual image of bread and drink, right? So, oh, that's a B. I figured that drink. Okay, that's a D. And so when you're in this situation, you don't even have to do that, because in your head, you can imagine your hands and think, oh, with confidence, I will take my drink, right? And so you're using visual imagery then to help you remember something that's spatial, right? Visual imagery also works when you're looking at something that is historic, right? When you're looking to see what happened first. So here we have a timeline. This is a timeline of different social media platforms when they were introduced, right? And so just visually, you don't even have to think about it. Visually, the items on the left happen before the items on the right, right? And so again, you can use this visual imagery. So if you're in a history test and you're trying to remember which battle happened before what other battle, right? If you have this visual timeline, you can imagine in your head, and that's going to help you remember what that information is. So learning associations, right? Okay, here we have. So I don't know about you, but when I first came to USD, I was like, what's a torero? I had no idea, right? And so, I looked it up. I'm like, a matador is their mascot. I can't figure this out, right? And one day I was walking back to the main parking garage, and on a little golf cart, this guy was sitting on the back. I don't know where they were taking him, but I was like, oh, a torero. Oh, I see what that is now. I have this image in my head. So now when I see the word torero, I think of him and I think, oh, okay, I know what the mascot is, right? And so this is the idea of using visual, right, this picture, and the word, I have them connected, and I have a much better idea of what's going on, right? So this is the idea of dual coding, that we code information. So again, we're thinking about cues, ways that we can retrieve information. If I have this coded as a visual and as a word, torero, right, that's going to help me remember that. So these are ones that I'm sure you're familiar with. So these are mnemonics. These are also mnemonics that rely on cues, right? So please excuse my dear Aunt Sally. I teach stats right now, and I have to say, I hear PEMDAS probably every other class. At least some student will, oh, PEMDAS error, right? And so this is something that this mnemonic helps you learn the order of operations, right? And so it's super useful when you're trying to figure out, oh, why did I get this stats problem wrong? Oh, parentheses, right? I need to do that first, right? And so this helps you remember. Same with the colors of the rainbow. I mean, what is indigo, right? The only reason I remember indigo is because it's Roy G. Biv. I remember that, right? And so these first letter mnemonics, they help you remember things in order, right? But they help you remember these things because they give you cues that are much easier to remember than what the actual items are. And the most powerful thing when you're studying, right, or trying to learn anything, is this idea of deep processing. So say you're trying to learn about, okay, you're learning about matter. What's the definition of matter? You can write it out. You're learning about the different states of matter. What is the definition of a solid or a liquid or a gas, right? So if you have all these out as definitions, you have to memorize them. That's a lot of work, right? But if you figure out how they're related to each other, so states, matter has different states, right? And these three states are included. These are the three names of the different states. And when you heat the different states, you move through, and when you cool them, you go the other way, right? And so, again, here you have them connected, deep meaning, these are conceptual meaning, right? You also have it visually, so that when you're, in the exam, you can sort of imagine, use your visual imagery, look at this and think, okay, so I understand how they relate to each other, and I can help remember it based on this visual, right? So, spacing when we optimize study, don't cram, right? Repeat the testing. It's better to spend, my son is taking physics, which is way outside of his wheelhouse, I have to say. He is an arts major. He's a BA, right? Or a bachelor, or a fine arts, right? So point being that he's taking physics, and I told him, I said, look, you have your physics. It's better to study 15 minutes each day than to study, a couple of hours right before the exam. And he tried it, and he said, yeah, it's working. So, it does work. And so then the repetition, doing it multiple times, right? You want to repeat it. And using cues. So you can use visual imagery. You can use dual coding. Mnemonics we're all familiar with, right? But finally, and most importantly, is this deep processing, right? That we want to make sure that we're connecting the meaning of things together. Now, what's interesting about these is that some of these are easier for people than others, right? And that's because we all have different cognitive traits. So when I talk about neurodiversity, I'm not just talking about, ADHD or, dyslexia, something like that, where it's like a defined thing that someone has. But we all have neurodiversity in the sense that there are all of these cognitive traits that are often normally distributed, right? So most people fall in the middle on these traits, but we've got people on the ends and sort of everywhere along that continuum. And so when you combine these traits, we can't see them, they're invisible. You can't look at someone and say, oh, you have really fast neural processing speed, right? It's not something that's visible. But when they're combined together, they make us all have a different interaction with the world, right? And so when you add all these together, they're literally innumerable variations. And so I'm going to go through some to make the point. So these are some that you sort of know that people are different on, right? And these are, most of the ones that I'm talking about, actually all of the ones I'm talking about today are very heritable, right? So they're things that are largely genetically determined. So how many of you here are math people? Raise your hands. Okay, a few people, yeah, okay, good, right? And how many, it can be, you can raise your hand twice. So how many of you are really comfortable with verbal, like writing essays? You prefer to, okay, so we've got some hands. So there's some of you who probably feel like, I would rather take an essay test than see a math test any day of the week, right? And there are other people who may not agree with that. It's like, oh, no, give me the math test. It's objective. I know what to deal with, right? And so this idea of mathematical reasoning versus language processing, right? So it's not a versus, because you could be good at both. But these are ones that we sort of accept that people are different on. Another one is visual and auditory processing. So some people, they learn things visually, easily, right? Some people would rather listen to an audiobook or watch something on YouTube, right? In fact, it's sort of a joke in my family, because my son, everything is audiobook, everything, he watches the YouTube videos, and he'll send me something, and I'll be like, is there text? Can I just read the text, right? Because my brain just isn't, I listen to something and I don't remember it, whereas he can remember something from, 5 years ago. He's like, oh yeah, I heard this, essay, and I'm like, really? Okay. And so this is another one where we have this intuitive sense, right, that we're different on these types of variables. But there are other variables that you may not realize people are different on. So visual imagery is one of those. So visual imagery is when you have your sort of in your mind's eye, when you can see things in your mind, right? So I'm actually going to ask you to close your eyes. So close your eyes and imagine a storm. Imagine the lightning. Imagine the rain coming down, right? So have a really good sense of that. So now open your eyes. So from a show of hands, how many of you had a really vivid image of that, like it looked like a movie? Okay, so really vivid. How many of you had one that was maybe more fuzzy or yeah, okay. Was there anyone who didn't have a picture at all in their head? Okay, so no one here. Usually in my cognitive psychology classes, I'll have at least one person who says, I don't have anything. I have no picture in my head, right? And I see people going, really? People don't have a picture in their head, right? Jacob, are you one of those people?
I was gonna ask, what if I had more audio than imagery?
Well, again, yeah, the way that you can have auditory images, you can have visual images. So some people can hear songs playing in their head better than other people, right? So a lot of musicians can, right? And so the idea is that we don't necessarily imagine that other people's experience of hearing songs in their head or being able to play songs in their head. Some of you might have you talk to yourself in your head, right? Do some of you talk to yourself? Whereas there are other people who, they look at you and say, you talk to yourself in your head? Really? That's a thing, right? And so with this visual imagery, when I do this, I do a more, a longer demonstration in my classes, but inevitably I'll have this one person who says, I don't have any picture in my head. And someone else who has really vivid imagery looks at them and says, you don't? Really? And then that person says, you do? Really? Right? And so this is, to me, what's so interesting as a cognitive psychologist, and that is that we have no problem understanding that someone may be more a math person than a verbal person, or someone may be more of a visual person than an auditory person. But things like this, these are cognitive traits that we don't have any sense that our experience is any different from anyone else. And I find that interesting. So another one is spatial awareness. So maybe some of you are really good at packing a car. My dad is great at packing a car. He can fit everything in, and I'm just like, really? Wow, okay, that worked. This is the one in my house. My husband's going to laugh at this. How well do you judge the size container to use for leftovers, okay? I kid you not. Every time I look at the leftovers and I get the container and he looks at me, he's like, you don't need that one that big. And I'm like, okay, really? Are you sure? And so I get the next one, and sure enough, he's right every time, right? And so these are both spatial awareness, right? But they're slightly different. I'm actually pretty good at packing a car, but I can't put Tupperware, I can't put leftovers in a Tupperware to save my life, right? And so spatial awareness is one of these variables where there are different aspects of it, right? So how well can you navigate in an unfamiliar city? That's also spatial awareness, right? And so when you think of something like spatial awareness, it's not just one cognitive trait where people can be very different, but it's actually multiple subsets of that trait, right? Attentional control. So in the extreme, you might have someone who has ADHD, right? They have trouble paying attention. But for any of us, we pay attention in different ways, right? We have different modes. So what's interesting about attention is that attention is probably the most limited cognitive resource that we have, right? So it's really, really hard for us to juggle multiple tasks at the same time. So we have to shift our attention. But it's interesting when you ask people, so how many of you study best with music? A few of you, right? Okay. Some people, they prefer music. Other people, they prefer, a coffee shop where there's low-level noise, right? So for some people, music is distracting, and they can't pay attention in their studying. Whereas for other people, they can't study at all without music, because if they don't have the music, then they'll get distracted, right? Some people have to have complete silence, right? I don't know if any of you are in that category. I literally, in grad school, I would go to the library. I would go to the library and put in earplugs. I mean, the quietest place on campus, right? But I don't want to be distracted, right? And so again, this is one of those situations where one tiny aspect of attention, and there are all these different, we are all fall on a different part of the continuum of it, right? Here's one that's a difference that people don't think is a difference. People aren't aware is a difference, and that is working memory. So people have different working memory capacities. And I'm going to actually give you a little test. No, it's a test, but it's not graded. So I'm going to give you a little test of your working memory. So working memory, it's not just what is active in memory. So if I'm going to bet you that a minute ago you were not thinking about a dog, right? You weren't? Any of you thinking about a dog a minute ago? No, no one. Okay, that's what I thought. But now you're all thinking about a dog, okay? You might be thinking about your dog. You might be thinking about, a generic dog, right? But you're thinking about a dog. So it's not just that now you have the dog in your memory, right? Or in your active consciousness. But working memory is what you can do with that, right? So now you think of the dog, and you can think of a dog wearing a raincoat, okay? And then you can think of a woman in a pink dress walking the dog wearing a raincoat, right? Okay? So you're actively building on this. You're doing some sort of work on whatever this is in your memory, right? And so one of the things that we test as psychologists is, if we're testing working memory, is to see if you can keep some information active while you're working on other information. And so this is an operation span test, and I'm just going to give you a little brief part of it. So the way it works, we show you a letter, we give you an equation, easy equation, we give you the answer, and you have to decide, is it yes or no, is it true or false, right? We give you another letter, another equation, yes or no, right? And then we give you letters, so recognition tasks, decide if you can, figure out the letters, right? So I'm actually going to give you just these first two, okay? Everybody ready? Okay. Okay, so pick out the two letters, keep them in your head, and those are the answers, okay? So most of you probably did pretty well, right? So now imagine that if I were to give you 3 of those in a row. Okay, now imagine that if I were to give you 4 of those in a row. You can see this starts to get really hard really quickly, right? And so this is a measure of how good your working memory is. And so this is another one of those where, would you imagine that this particular trait, you would be different than the person sitting next to you? Probably not, right? I mean, if you haven't taken cognitive psychology, you might not even know that this was a thing, right? Until tonight. And so it's just an example of all of these cognitive traits where people are very, very different, right? And we combine these traits together, and people become even more different. We talked about mathematical reasoning, language processing, auditory and visual processing, visual imagery, spatial awareness, which has multiple pieces to it, attentional control, which has multiple pieces to it, working memory, right? These are all traits that we don't see, and we don't really necessarily realize that people are different on them, and on and on and on and on and on, right? So many of these. And then we add on to that, so as if we weren't already very different, right? We add on to that experience, okay? So when we are viewing information, we're human information processors, right? People are designed to process information. We can't help it, right? And so when we are thinking about these cognitive traits, that's part of this bottom-up processing, that we take in our sensory information, right? We integrate it, we assemble it, and then we figure out, what is this, right? And that's based on our experience. So you have a little kid who's walking along the street with you and sees a Great Dane, and they say horse. No, it's not a horse, it's a dog, right? And then they see a chihuahua, and they're like, cat. No, it's not. It's a dog. It really is a dog, right? And so this experience then, it allows us to make sense of what we're taking in, right? So how well we collect information is based on our cognitive traits, and then our experience affects how we interpret information. So imagine you are going to your friend's house, and you walk up to the front steps, and there's this small animal, has a collar, is wagging its tail, is really cute, right, whatever. You say, oh, it's a puppy, right, okay? So now your friend opens the door, and your reaction, so your cognitive traits, your bottom-up processing, identify that it's a puppy, right? And now your top-down processing is saying, oh, is this your dog, right? The puppy should not be out where it can get in the street, right? So do you want to take it in the house? Even if it isn't your dog, let's take it in the house so that we can find out whose dog it is, right? Okay. So now imagine, different day, you walk up to your friend's door, a small animal sitting on the steps. It's cute, it's little, it's got a striped tail, it's got like black patches around the eyes. You say, oh, it's a raccoon, right? Your friend comes to the door. Do you say, oh, we should find the owner of this raccoon, right? We should make sure that the raccoon doesn't get in the street, right? No, we don't. Because our top-down processing, right, our experience says, make sure, close the door, quick, don't want the raccoon to get in the house, right? And so this idea of our experience, we have our cognitive traits allow us to integrate information, right? And then our experience allows us to figure out what to do with that information, how to react to that information. Tell you, our friend would not like it if you shooed the raccoon into their house. So when we think about this, then, that every person's subjective experience of the world is unique, right? So if I were to ask at the end of this talk, if I were to say, just write down what the most important thing you learned tonight, right? I'd get wildly different answers, okay? But if I ask people to just remember, write down everything you can remember from this talk, I'm still going to get wildly different answers, right? Because your cognitive architecture is different. What you pay attention to is different. Your experience is different. And so even though you all shared this experience here, the exact same experience, your subjective experience of this talk is going to be different, right? And this is something I tell my students, and I'm telling you tonight. Now I think of last lecture, what do I want to impart to people? That a lot of these cognitive traits, they're not visible, and we don't even realize that they're differences, right? We sort of assume that everyone's subjective experience is the same as our own, right? But in fact, everyone is experiencing a different reality than you are. And so I think it's really important with an understanding of how we are so different, even though it might not seem that way on the face of it. I mean, we look different, right? But the way that our brains work is different. That give each other grace, right? If someone interprets something differently from you, most likely it's just because their brain is wired differently and they have different experience. It's not that they're a bad person. It's not that they, are, maybe they're wrong. I don't know. But it's not, there's no nefarious intent, right? And so I think understanding how we are so different is actually really useful in life, that it can help you interact with people better. It can help you understand people better. It can help you in an organization get the best out of people because you're able to meet and understand them where they're coming from and understand that they are coming from somewhere different, right? And so I think it's really important, just this awareness that our subjective experience of the world is unique, right? We all are experiencing the same thing in a very different way. So that leads us to AI, right? How is this human experience then different from AI? So AI is built on learning algorithms, right? So there is a lot of work that goes into programming them. They're trained on data. They're trained on massive amounts of data. But what's important to remember when we think about how AI can think, it's important to understand that this is based on what humans have already done, right? So AI can't think of anything that you haven't already done because it's not in its training. So I was preparing this talk, and I thought, oh, well, this is a good chance for me to see sort of what are the limits of AI, right? So I pulled this off the internet because I thought, oh, this is a great visual of our deep processing and how we make connections. But you notice that the text is kind of wonky and it doesn't look great. And I was like, oh, well, this should be something that AI can help me clean this up, right? So this is the actual thing that I asked AI. Can you improve this figure? So to be fair, I used ChatGPT, which I know large language model. It's not some vector AI that could be better at this. But also, ChatGPT has sort of become accepted as the interface between people and the different AIs. So it's going to send it on to a more specialized AI. So I thought, well, this is a good test. Let's see. So I went back and forth 2 or 3 times, and I came out with this. I was like, this is good. I like this, right? I don't like, I'm not a big fan of these boxes, but it got it, right? So, as I said, this is about the 3rd or 4th attempt. So I said, okay, great, I'm almost there. So I'm going to ask that. This looks great, and of course, you got to tell the AI, great job, because you don't. When it takes over, you want it to be nice to you. Right, so this looks great. The only thing I'd like removed are the boxes around the arrow labels, right? Okay. So you all know what I mean, right? I just want these lines erased, right? Okay. This is what it gives me. wait, what? Heated is here, and wait, and that's not even a word. Like, it changed the spelling. What's going on? Okay, and I was like, oh, okay. So in my cognitive psychology classes, I do this exact instructions challenge, right? Dr. Getz knows exactly what I'm talking about. In fact, I use her video for that. So the idea is that you have to be really specific about what you want, or you're not going to get it, right? Because I have assumptions that the AI doesn't necessarily share. So is that good? I know how to do this, right? Okay, so I tell it again. Let's see. This is really good. Don't change any arrows or labels. Just remove the boxes around the words has different, including heated and cool. I'm like, okay, exact instructions. Should be no question. I'm like, well, I mean, it's good, but then you took the label away from here. And what is this? How do I know? I no longer know which direction I'm going because it's just saying it's both directions. I'm like, but I'm so close. I'm so close. Okay, I've got this, right? Okay, start again. So you change the arrows. They should be the way that you made them in the previous figure, okay? Oh my gosh, what have I got? Like, what is going on? This isn't an arrow. It goes both ways. There's one here. I have no idea. And just to be clear, that was the previous figure that I was talking about, right? Like, it's not the same. Okay, at this point, I'm like, you know what? I got to give this talk before the end of the semester, so I'm going to, just do it on my own. Okay, so you remove the down arrow for heated. You remove the label. I'm going on. Trying to be exact instructions challenge. Could you put these back? But no other changes, please. No other changes. No. Okay. So this is not AI. This was after 25 minutes of beating my head against the wall. I spent 5 minutes in PowerPoint and made what I wanted, right? Okay. And so again, sure, AI is improving, but AI actually is improving slower than you think, right? Because the big advances in AI have already, or at least in large language models, have already happened. There's only so much more that AI can learn from the training data, right? Because it's gotten 90% of the way there. So I'm not sure it's going to get better at this. But let's talk about what AI is good at. So AI is good at tasks that involve patterns, repetition, large-scale data processing. So if we're looking to diagnose diseases from medical images, great use for AI, right? AI can match those patterns and say, oh, this may be cancer, right? Fraud detection, it's like, oh, this is suspicious activity. AI is really good at that. Routine and repetitive tasks, right? So transcribing audio, AI can have it, right? You imagine these poor court transcribers who, you see them in old crime dramas where they're, can you imagine doing that for 40 years? Take it, AI. I don't want that, right? Tagging photos. I love it. I go on my phone. I'm like, I want to photo my dad. It gives me all the photos I've taken the last 10 years of my dad, right? It's a great thing. I never would have the patience to go through and organize those. Playing games in well-defined environments with clear rules, right? So one of the things, people say, oh, AI is so good at chess, right? It's so good at Go, which is a really complex game that, humans have a really hard time with. But the rules are very clear, right? And so AI can crunch the numbers computationally and be better than humans, right? But how are humans different from AI? So think back to what I was saying earlier about how we have all these individual differences, right? So in addition to the cognitive traits that I was talking about, personality traits, plus we have experience, right? And so the training data that AI is getting is based only on our visible output, right? Think about all the essays you haven't written yet. Think about all the, for an artist, songs that they haven't made, right? That your visible output is just a fraction. You think about it like an iceberg, right? It's the tip of the iceberg of who you are, right? And so AI is only trained on this bit. And we incorporate new experiences into our consciousness minute by minute, right? You all are different people for having come here tonight, right? You all, even if you're in my classes or have been in my classes, you all probably have learned something already that's different and that changes your outlook on the world, right? AI, you've got the algorithm, it's doing its training data, it's doing its thing, right? It's static until you create a new model, right? And by the way, those models aren't cheap, right? Those models, enough electricity to power, I think it's 500 US homes for a year, is one of those models, right? So this isn't something to take lightly, and this is something that you all do every minute, right? And you don't even think about it. So one of the things when I think about how AI is different than people is this idea of generativity, right? That we can create new language, right? And it's not just the creating new language, but it's that we create new things, and so we create language to surround it. So this is a 5 megabyte hard drive from 1956. Okay, I know, looks pretty big, right? How many gigs do you have on your phone in your pocket, right? I mean, and yet this. And so you think about it. When I was born, I know I'm old. When I was born, there wasn't the phrase personal computer, because computers were these big things in round. I mean, people were working on them, but you couldn't buy one, right? And so personal computer, this phrase, it referred to a computer that could live on your desk, right? Okay, that's great. And so then people shortened it to PC, because who wants to say personal computer? That's really long, right? And so we can use these words, right? You didn't know that's what it was. No, that was the acronym. I love it. Oh, so see, you just learned something new. So it's like TV is television, right? So point being that we can use that word PC, right, as a noun. We use it as a noun. We don't have any problem with it, right? And then that spurs new language. So an Apple was a personal computer until it came out with Macintosh. And now we have Macs and PCs, and well, Macs are Macs, and then PCs is everything else. And so we understand this, and we can incorporate this, right? You social media, if I DM you, right? Okay, you know what that means. Your grandfather might not know what that means, but if you tell him what it means, he may have never done it, but he can still say, oh yeah, I DM'd you yesterday, I'm going to DM you tomorrow. Stop DMing me, right? That we have the ability to not only create new language and to use it, but to understand these new concepts, right? That the language represents. So large language models, they can't create new words. They can only learn by example. So they only know what DM means and how to use it because it's seen us do that, right? It can't come up with something new. Because AI can't reshape or recombine existing knowledge. And this is really important, right? That this is something that humans are uniquely good at, is recombining knowledge in new ways. Another one is problem solving via analogy, that AIs are really bad at this. So when we have smaller and smaller electronic components, you generate a lot of heat, right? You can't fit a fan in these new laptops, right? You have to figure out something else. Conduction, like if you want to conduct the heat away, that's too slow. It's going to fry the electronics. So you have to figure something out. And so what scientists came up with is this idea that's based on blood flow, right? So the brain generates a lot of heat, and it doesn't overheat because the blood moves to your skin, right? It cools down, and then that cool blood goes back and cools down your brain, right? It takes the heat away. And so that's how modern laptops are cooled, right? Is that you have these pipes that have liquid in them that evaporates when it gets hot and then condenses when it gets cold. It circulates, and it pulls that heat out just based on the human circulation system. And AI can't figure that out, right? And AI would never have figured that out because that's not how it's trained. Humans figured it out, and so now AIs can say, oh yeah, there's this technology that does X, right? But a human had to create it in the first place. So AI systems, they don't understand this relational aspect, right? So, when I came back originally I was talking about how deep processing is something that's really useful in order to learn information. That ability to create these relationships or understand these relationships is uniquely human. So yeah, AI, they can rely on statistical associations, but they can't actually do that sort of conceptual mapping. Intuition. We experience the world, and that teaches us lessons that we apply to new situations. So if an AI knows that ice melts in the sun because it's learned it from these, thousands and thousands of training data that it gets, right? But a toddler could tell you that, right? Because, the ice, when it gets warm, it heats, better not put it in the sun, right? And so these are things that we intuitively, intuition, that we learn without even thinking about it, that AI can't do. And then the last is insight, that as humans, we connect to each other through shared experiences, right? So when you are talking to a friend and they're having a bad day, you know, you say, oh yeah, something like that happened to me and this was really helpful to me. Maybe it'll be helpful to you, right? And so we share experiences. We when we're looking at art, and this is one for my kids who are both artists, that I try and remind them that, you know, we're emotionally moved by art that speaks to our personal experiences, right? And AI can generate art, it can generate music, writing, but it doesn't have any experience that it's drawing on. It's just mimicking. It's just, you know, copying what we've done, right? And so the human advantage is then understanding nuance and content is huge. Originality, genuine creativity and originality is something that we have that AI doesn't. Emotional intelligence and empathy, AI doesn't care. And in fact, there have to be guardrails on AI because, you know, we had some problems with early large language models where people were doing bad things because the AI didn't care, it had no understanding of feelings and how it was going to affect people. And flexibility, this one's huge, that we as humans can adapt to new situations, right? So my dad was reading a book about, it's a famous runner, it wasn't famous to me, but anyway, it was a runner who he had heard of, who was captured during World War II and was on a raft like for 46 days in the ocean and managed to survive because he and his buddy, they caught birds and they had rainfall and all this kind of thing. Like that adaptability to be able to survive in that type of situation and to be able to sort of think creatively, that's a very human trait, right? And so you hear stories like this all the time, but an AI would only know to do that if it had seen an example of other people doing it, right? And finally, ethical decision-making and moral judgment, right? AIs don't have morals, so big difference. So the takeaway, AI is really impressive at some tasks, right? But there's still a lot of things that humans do a lot better. So that's definitely. And then just sort of closing thoughts. You know, to think of the ways that that your mind works differently, that your mind works differently from other people. That's going to help you figure out what way for you to learn most efficiently. But it's also going to make your life experience better, right? The idea that you can understand that other people are not experiencing the world the same way as you are will make you happier. It'll make you more successful in life, right? And then the last takeaway is don't be afraid of AI. Be the master of it, right? AI doesn't have any desire to take over the world. It's only basically programmed, I mean, unless we really screw up, right? But it's only as good as the algorithm. That we create algorithms and the AI follows them, right? We give it instructions and the AI follows it. So understanding what you can contribute above and beyond that allows you to use AI as a tool. So thank you very much. And I was told there's Q&A, so yeah.
I have about 30 minutes for Q&A.
Yeah, so any questions you have? Yeah, go ahead.
Super interesting, especially the part about AI. I think that's like a very relevant topic right now. I know you have a bit of a background in business, and do you think that creativity will be a much more valued and marketable trait now, like as AI becomes more pervasive and you have this starving artist kind of stereotype now? Do you think we'll almost revert back to artists being like the more valued people because of AI?
Well, absolutely. If you think about the tasks that AI is good at, if we can farm those out to AI, that actually frees us up to be more creative, right? That we have more time to be creative, and we can offer that. You know, businesses don't have to pay for the easy stuff, right? And so they're going to want to be paying for these things that are going to make them different, right? Because businesses, that's how business succeeds, is if they're different from other people, and the only way they're going to be able to do that is to have these creative people driving that.
Super interesting. I'm excited for that to happen.
Yeah, me too. All right, other questions? Yeah.
Would you say that like AI has a more reliable memory than humans? Because I know you were saying like, you know, each of us are going to remember different things. So because it's like a computer that runs on algorithms, like is it more reliable?
Right. So when humans are remembering something, it's largely reconstruction. You're using the cues to reconstruct what has happened. And so every time you actually, when you're retrieving from memory, you're actually changing that memory. So this happens a lot with people where you'll have a conversation with someone. This happened actually after 9/11, where people would be interviewed about what happened on 9/11, and then they asked them a year later. And because it was something that everybody talked about, people's recollections of what they experienced actually changed. Because every time they talked with someone, they would start to get confused about, was this something I experienced or my friend experienced, or did I see it on TV, right? And so, yeah, absolutely. AI is going to give you a more objective record, in the sense that, like a video recording would give you more of an objective record, right? But the synthesis is going to rely on humans, right? Synthesizing that information to make it meaningful, that's a human trait. Yeah.
I was wondering what was like your biggest finding of inhibiting your memory? Like, is it drugs and alcohol? Is it trauma? Like, what is it? Like, it's sort of like the number one thing to make it so it's harder for us to remember things.
So what's interesting actually is that forgetting can be important, right? So do you drive to school?
I do.
You do, okay. Do you park in the same place every day?
No.
No, okay. So imagine, you know where you parked today,
Yeah.
right? Do you know where you parked 3 weeks ago on Thursday?
No.
No, you don't, exactly. It would drive you crazy, right? And so humans are sort of designed to remember important things and forget things that they don't need, right? And so forgetting actually is a normal part of life, right? And so, you know, when you think about, certainly there are outside impacts that can cause forgetting, right? But most of forgetting is disuse, right? So if you are CPR certified, it's not for life. You have to go back every year and get recertified, because unless you use that information, unless you retrieve it and do it and try it, you're going to lose it, right? And so that's a much bigger impact on forgetting, right, than one of these outside types of shocks. Yeah. So the key is, if you want to make sure you remember something, is to keep revisiting it, to keep relearning it, right?
Is the working memory exercise we did, if you practice that on your own, will that make your working memory in other areas better, or is it just doing the retrieval with specific information?
No, so working memory is largely heritable, so there's a big genetic component, but that doesn't mean you can't improve it. Absolutely, you can do tasks that, in fact, they're computer tasks that you can do that will help you improve it. Yeah, so practice helps. Yeah.
So if humans have produced algorithms to create AI and make it running, this is like more of a theoretical question, but do you think that AI can break that interface and like develop its own?
I was going to say, you're asking about consciousness.
Yeah.
My belief is that no, that AI might mimic consciousness, but I don't believe that AI would have consciousness in the same way humans do, right? So, I mean, and I think that because it has no desire to be conscious, it just has a desire to do what you ask it to. Yeah. And you can see that sometimes because you'll ask AI something. I actually tried this the last time I taught stats. I was asking it stats questions. It like wanted to give me an answer, and I would look at it and be like, "This is wrong," because I wanted to see what my students were doing, right? And I would say, "This is wrong," and they'd say, "Oh, I'm so sorry," right? Because it just gave me something because I asked, right? So AI isn't trying to, like, there's no intent there, right? Yeah.
This isn't about AI, but I was just curious about like your interest in psychology and diet. Like, could you talk a little bit about that?
Yeah. So I actually spent several years at UCSD. I was in an obesity lab, and so we did randomized control trials for weight loss. And as a cognitive psychologist, my role was to look at how cognition changed, right? And so we found all sorts of interesting things. We found that we could improve people's memory with diet. So we did a study where we changed, and this was actually in elderly people. So you can change, you can improve even when you're older. This is ages 70 to 85, and we changed their diet, and that's it. They didn't do anything else but change their diet, and in 6 months they were improving on their they improved on their memory scores, right? So that's one. So the diet would be we had them eat blueberries, omega-3s, right? Those kinds of things. Other types of things that, not necessarily things that we've done in my lab, but that things like processed foods, right, can cause inflammation, which causes cognitive issues. So, you know, you want to eat things where the rule of thumb is if you look at the label and you can't pronounce it, you probably don't want to eat it. Right? You know? But those things, they're not just bad for you. They actually can have cognitive repercussions, right? So it's not even necessarily like eating healthy foods, but just eating real foods can help.
Was all the work you're doing with humans?
Yeah, so in the lab it was all with, we did children's studies and we did adult studies, a lot of fMRI studies, and then behavioral. I did all the behavioral work there, so.
Very cool.
Yeah.
Thank you.
Yeah, sure.
Why is like retrieval in more stressful situations like so much harder for us? So it's like if I study like how you chose for like how you shared us for a study for a test, it's like I get in there, I blank. Like,
Anxiety.
Why? Yeah.
Yeah.
Okay.
Yeah, so when you're in an anxious state, you're not able to. It's a focus of attention, right? That in order to have successful retrieval, you need to focus your attention on that, right? If your attention is focused on, oh, I'm nervous and I'm anxious, then you just those cognitive resources are pulled away from what you need to do that correct retrieval. So.
This might be like kind of a loaded question, but you were saying like, oh yeah, like AI can't have any sort of like moral compass, like it can't make ethical decisions. So like, how is the way that like humans learn ethics? Like mom and dad said this is wrong, and like now that's what I believe. How is that different from AI being like, oh, like I've read philosophy that says that this is right and wrong? Like how is that?
Yeah, I think obviously training is important for ethics, but also as humans we understand emotions, right? So if you watch two little kids, like 2-year-olds playing with each other, and one pulls the toy train away from the other, and the first one starts crying, right? That's a really visceral, like that second kid knows that wasn't right, knows that hurt the other person's feelings and that person's upset. Now, they might not do anything about it, right? But like part of ethics is understanding how other people, and some humans are wired differently, so they don't respond to other people's emotions. But most of us, right? Most of us, if we do something that makes someone else upset, we want to fix that because that doesn't make us feel good, right? And so a lot of ethics is being able to put yourself in someone else's position, and an AI can't do that because it doesn't have a position. It doesn't have a sense of self, so it can't possibly put itself in your shoes because it doesn't have a self to begin with, right? Yeah.
Can humans like operantly condition AI
Ooh.
based on the way that we chat with them?
Oh my gosh.
That's a good question.
I talk to my Snapchat AI pretty much all day, every day. That's my
Well, I mean, AI learns. It learns how to respond, right? But yeah, I would guess that it just is responding based on, you give it feedback that yes, that's right, and so then it gives you more of whatever it's doing, right?
Yeah.
So.
You need to be nicer to it.
I know you saw me. I was like, "Good job, AI." That's funny. All right. Other thoughts?
You want an opinion from me?
Yeah, I do. I was looking at you because I'm like, do tell. Yes. This is my
Large
husband, by the way,
language
Jason.
models that they only learn in their training, which is a huge computational effort. That that's what she was talking about. Powering 500 houses per year. That's a small. So they're not learning morals from the conversation with you per se, unless that conversation was then included in the training set the next time around. But you can give like ChatGPT instructions, right? And it can remember those instructions for a period of time, or you can set them in your account instructions, right? And so that you can alter its behavior with regard to you for that session. But it's unlikely that the AI years from now is going to remember that you were nice to it.
All right. Well, if there aren't any other questions, thank you for having me, and please get some food.